I was just demonstrating that the different options for the type of database
Yeah.
don't work. It throws an error message and saying um, this type is not valid. It needs to be file. So I was just
Mm.
wondering if that's something just local for me, or if that's something where maybe those were some options put in early but no longer have support. Um, and I don't know, I've tried using the database thing before, because actually it was primarily because I had issues with the reset command that I had pointed out earlier this year on the GitHub. And Michael, I think you fixed that, right? With the
Which,
fatigue material.
oh yeah. Something
Yeah.
wasn't getting,
Yeah. So I was
yeah.
trying to use a workaround by using the database to have it reset back to a previous state. But I was just wondering if anyone actually uses it, and I don't know. I think it would be interesting to talk about. It's not as commonly used, but it's there.
Yeah, I suspect, but I'm not 100% sure that the MySQL and the Berkeley DB, they're just probably not supported anymore.
Yeah.
That's my guess. The files one, it just writes out information to like files, so that's like always going to work, I guess. Uh,
Yeah.
and then
It.
maybe depending on what version of MySQL or Berkeley DB is installed on your local machine, it, this OpenSees implementation may not have been, maintained, to
Mhm.
match the latest versions of those database
Gotcha.
uh, engines. But even if they do work, or let's say even with file, right? Uh, it's not integrated into all the element material types as uh, as you're asking, I think in the post, right? Uh,
Yeah, I was just asking to see if it's actually viable or if it's pretty much like
well, actually,
not
there was
recommended to use it.
there. Well, depending on what models you're using, but there was actually a GitHub issue with this week, and
Oh, really?
I'll pull it up, and then maybe that can kind of show the issue. Uh, because it also affects like if you're going to use OpenSees MP and SP, it's
Oh,
the
yeah.
same functions. So let's see. Like here, this was 4 days ago. So somebody was using Steel 4 in a parallel analysis, I think with OpenSees MP or something, right?
SP looks like, yeah.
Or SP, yeah. And then like they got this warning that said, trust receiveSelf failed to get a blank material of type 87, right? And it's because the Steel 4 material, well, a few things, right? One, Steel 4 wasn't included in this object broker class,
Okay.
which is kind of the object that like manages, like when you have different processors or when you're writing to a database or loading from a database, the object broker will create like a blank Steel 4, let's say, and then call receiveSelf to write all the data into that blank Steel 4 on
Gotcha.
your remote processor or on your database or wherever. So that's why the receiveSelf and the sendSelf for the element failed, was because the object broker couldn't create a Steel 4, right?
Hmm.
So the way this was an easy fix. All we had to do was go into this Steel, or sorry, FEM object broker all classes. Uh, Last commit, and we just had to add. There's like just a big switch statement
Yeah.
in, and we just had to add, if it's mat tag Steel 4, which is defined in class tags.h, right? Just return a blank steel 4 material.
Yeah.
Right. But then, so, that's step one, right? If you want your materials to work with databases and OpenSees SP and MP, I assume. But then if you go into the material, you also need to have sendSelf, receiveSelf implemented for whatever materials you're trying to ship between processors or into databases, right? And not all of the materials implement sendSelf and receiveSelf. Same with the elements. So you have to be a little bit careful. But I think it's implemented for steel 4. Oh, no, it's not.
Return
See,
-1.
so that's just the default, like do nothing. So this person is going to run into, they're probably going to make another GitHub issue soon, I bet, saying steel 4 is not shipping between processors because sendSelf and
Yeah.
receiveSelf are failing because they're just returning -1. So what should these functions do?
So,
All right,
so that should only be an issue on SP, right?
I still
Is
don't really understand the
MP is just
via.
multiple processors, but it should.
Oh, okay.
So it
Yeah, so
runs the same script on
SP,
multiple processors. So
yeah, okay. Yeah, so SP and database stuff, right?
gotcha. Okay. So there's
Those
just be an
both call
issue
these
on.
functions, yeah.
Got it.
But then
Okay.
let me show you what those functions should do. Let's go to Steel01, the OG steel model, right?
Curious as to what the steel 4 is.
Do
I
what?
think Steel 4 is very specific to BRBs.
Yeah.
I can send. I can. There's a dissertation which goes through the development of it. So I
Well,
can
it's
share that if you
documented.
want.
Yeah, it's nicely documented too.
It is, yeah, it's extremely nicely documented. I mean, it was calibrated from a ton of tests and stuff. So it is the material to use if you want to model BRBs.
Why not just regular steel? Anyways, that's a whole other topic.
It's
But like
it's
here,
specifically modeling the BRB component as a single truss. So
Okay.
it has different capability for different
different
strength and
tension and
compression and
compression.
compression. Yeah, exactly.
Oh, very nice. Okay.
So like here's Steel01 sendSelf, right? And what it's doing, you see, it's not just return -1, right? It's doing some stuff, and really all it's doing is it's declaring a vector of whatever the appropriate size is, but you're just jamming all the state information into that vector as well as the material properties. So here's the material properties for Steel01. It's just going into the first. The first entry is the tag data 0. And then the material properties, just packing it into a vector. And then the history variables it needs to recover its state on another processor or on another database, or when you load your model in from a database, right? And then it's calling, send vector. It's just sending that vector through the database tag, and so it's doing something, right? And then it's just returning the results of that. So that's what all the materials should do, but not all the materials do that. It's not implemented just because. And I've done this before too with materials. I just don't feel like doing it, so I just say return -1, and I'm like, oh yeah, I'll do it later, but then I don't do it later, and then people copy that right from into Steel 4, and
Oh
then
boy.
it just propagates. So I'll take some blame for that. But at any rate, this is what should happen, right? That's sendSelf. It's sending a vector, right? And then receiveSelf, after the object broker creates a blank Steel 4 or Steel01 or whatever on a remote processor or in memory when you're loading in a database, it receives that vector, right? And then just dumps everything back into the material properties, the tag, the history variables that it needs to recover, and just recovers its state right in here, and then then it's ready to be used. Right? Let's see.
I just dropped the file in the chat. It's uploading right now.
Oh, okay. Yeah, it's still no files there yet, but
No.
But I so like the Steel 4 needs sendSelf and receiveSelf, and
Gotcha.
whoever made that issue on GitHub,
Is it gonna have the
they
same
probably
problem?
they probably just haven't gone back and tried it yet, or compiled the new code, or
Yeah, it should be up now.
oh yeah, there. Okay, well, 38 megabytes.
It's a thesis, so
Okay.
actually a dissertation, so it's relatively short for a dissertation. 152 pages though,
Okay.
so not too bad.
Yeah. Okay. So I can just write in here, note, Steel 4 still needs sendSelf, receiveSelf to be implemented. So yeah, I mean, but if you're writing a new material or a new element, or most materials and elements, and you want to use databases or SP, yeah, you have to do sendSelf, receiveSelf. Don't just blow it off, right? And then also add it into the FEM object broker all classes. This file right here. So it's on the record, right, Sylvia? Yeah.
That's useful information in general too. So okay. So the database command isn't really so that then we can query a database. It's literally to just dump the domain and everything.
Yeah,
On
the state
storage.
of the domain,
Right.
so that you can do it, like restart. Like, for example, like I've done some earthquake and tsunami sequential analysis, right? So like we want to do one ground motion, and then run tsunami analyses as static loads, right? With different wave heights and flow velocities, but the preceding earthquake's the same, right? So we would run an earthquake, 300 seconds long duration type thing, and then save the state of the model to the database, and then for every flow height and velocity, just restore from the database, and then do like the hydrodynamic pushover analysis, and then do a different wave height, but restore from the earthquake, and then so I mean, that's one, like for sequential analysis, it's pretty useful.
But what you're saying is, if you were using Steel 4, then that wouldn't work though, because it's not storing. You would be able to restore.
Or fatigue material, for example, it wasn't restoring itself properly. Like it wasn't setting. It was not setting, or perhaps over or resetting too many things that it shouldn't have. I forget what the case was, but it wasn't reconstructing properly. Right?
Yeah, basically, if you had a fatigue material and you did the reset command or something and analyzed, it would basically say that all the fatigue material is fractured. So
okay.
I think it set like the strain to like some ridiculously high number or something. There was just some bug with it.
Okay. So you can use this command, but you have to make sure that, no, not I guess the OpenSees management needs to make sure that all the materials do certain things. So, okay.
Yeah, I can try to find or I guess keep talking, but I'll
No, I think
It should be
yeah,
on GitHub, right? I can show what Alex is talking about. I think it's
yeah,
it's good to.
The issue that I brought up.
yeah.
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 Well, it's handy to have. I haven't done sequential analyses like that, but that's a nice feature and implementation to use. But if it's not reliable, it's
Yeah,
kind of
that's the thing. Like you have to go in and make sure that all the model elements and constitutive models you're using are working, or that they have those functions implemented. But even then, it's it may not work.
okay. But you
Yeah.
haven't had problems because you use just the main original OEM version of OpenSees, right?
Right. Yeah. Yeah.
Okay.
But
Well,
like here's what Alex was talking about. This is from over the summer, but basically within revert to start, which is this is a little bit. This is not a sendSelf receiveSelf thing. It's a reset thing. Or you were trying to do a workaround using reset or something, but
I was using reset. I was actually doing post tensioning of a doing steel post tensioning and trying to get the final post tensioning force to equal a certain amount. So I was using reset as a way to do that.
okay.
But I found a workaround since then that actually works really well. So
what does
Okay.
reset do?
So reset when so there's a command in OpenSees called reset, which works for takes the whole model back to its initial state, like without doing wipe and then reconstructing the model.
Oh, okay. So it just pretty much. How is that difference from wipe analysis? I mean, I guess it keeps the analysis
Yeah, it
and
keeps the
object.
analysis. So wipe analysis just clears out the analysis options, right? And then
Oh, it doesn't remove the analysis results, though.
no.
You're right.
yeah, it just
Okay.
takes you back to t equals 0, basically.
Right. But it doesn't remove the state. It doesn't bring the state back. The wipe
No,
analysis,
it
the wipe
resets
analysis, right?
it resets the material state and everything.
The
Reset
reset
does.
command.
Yeah, reset
Yeah.
does.
Okay.
Yeah.
Oh, okay.
But it calls this revert to start on all the materials and elements. And what fatigue material was doing in revert to start, it was setting these variables to 0. But these were parameters that
Input parameters.
these are input parameters, right? So min strain and max strain were set to 0. So yeah, like Alex
Ah,
said, it would like instantly fail because the min strain was 0 and the max strain was 0 instead of whatever you wanted it to be.
so this almost seems like it was not the original person who wrote the material actually had to went in and edit this, and they didn't know what min and max were, and so they assumed that they were internal variables. Okay.
Yeah, it's. I mean, we could trace back through the
Yeah, but that's what I'm
history, but
guessing.
I just had to
You
I
know.
just
Yeah.
remove these statements, and then I think it worked, or at least it didn't overwrite the input
Has there
parameters.
been a new version of OpenSees since you made this change?
In Python, yeah.
No.
Oh, you are. That's extortion, Mike.
That is.
No,
That is pure extortion.
it's so much easier to just compile the PIP package in Python than to post the Windows executable on the OpenSees webpage. But
Yeah, because you have to go through Frank.
right, that's the problem. Right?
Uh,
Yeah,
But I think
actually,
the last version was sometime around June or July. The last OpenSees
I think so.
IDXE.
Yeah.
Yeah.
I think. Yeah, Michael's gonna show me how to compile it on my own machine because.
Yeah.
yeah. Well, I was thinking this could be a good educational video or, kind of tool to put out there, Mike, on
Yeah.
it's not just, and I think it's useful also to where we're going to go with Christian. It's like, it's one thing to just write out a material. But then there's all these little things that people don't even know that they were supposed to do when they implemented a material, such as updating all these other files. So I think this would be a good information to get out there.
Yeah, just like the importance of sendSelf, receiveSelf, and even revert to start. I mean, that one's fairly straightforward.
The send and receive self almost feels like you can almost write a wrapper around it of saying, okay, tell me what the variables are, and then they just get stored in an order, and then you pull them out in the same order. I mean, it doesn't seem more complicated than that.
Well, yeah, it's just the wrappers, or any wrapper wouldn't have access to all that private data.
Yeah.
So
right.
that's, but yeah, it could be like FEEP, right? Just you have a common block, and you write into a vector, and then it's all common data. But
yeah, or as you define the material, you just give these are the input parameters that need to get sent and received. So.
Yeah,
but then if you go to like steal or go ahead, Alex. I'll bring up something else.
I just had something I could share regarding that. So I mentioned before that like sometimes I'll wrap OpenSees commands and then put my own monitoring stuff on top of it in the Tickle version. So one thing that I've done for uniaxial materials is I wrapped that command and then stored all of the input uniaxial materials. And then if I want to run a uniaxial material test, I just open up another interpreter, I open up another execution of OpenSees and just send all of the uniaxial materials and then run my uniaxial material test. So similar sort of concept of just storing the inputs and then recreating it.
Yeah, but you do this in Tickle.
Yeah, I do. Yeah, I mean, I don't know if you can do it in Python, but
no, but you don't go into the source code. You actually, this is in your Tickle script. You have
if you're clever about it, you can actually kind of have local storage of a lot of geometry data and analysis data. So
yeah, that's how I do my easies. Is you build the information, and then that can dump either to just a file that has the data or to an OpenSees command.
Yeah.
So just managing your input above that. So, okay, cool.
So I just wanted to, some of these materials, does anybody use this reinforcing steel? This one?
What do you, I'm curious about it because I had tried using it forever ago when it first came out, and I couldn't even do a moment curvature analysis for it. It seems that people are now using this material. Anybody, do you have experience with it, Mike? Or
no, but I looked at it for some reason a while ago, and I was just, there's like 20 parameters, and B, there's like, this is all the private data down here, right? Double. All of this stuff is like state information. For one fiber of steel, right? My point is the sendSelf, receiveSelf, it will be like you need a vector of like 100 values to jam in there, and then.
Well, this explains why I couldn't do more than just a moment curvature analysis on more than 2 fibers. So.
Yeah, it's complicated. Is my point. And there, even some of this converged data is an array, based on some variable. There must be 200 floating point values required for the state of this material, right?
Okay, this explains a lot. Thank you for giving me.
You may just run out of memory or something. I don't know.
and maybe that's why it didn't work 4 years ago, and now it works in my bigger, more powerful machine.
Yeah. Data. Speed is not a concern these days, but data storage is, right? When you take this and multiply it over all the fibers in your section, all the sections in your element, and all the elements in your model. Like,
Yeah.
I mean, this is more calculation and more storage than like, like, anyway,
Anything else?
I'm
Yeah.
ranting a little bit, but
Yeah.
I'm sure it's a
That's okay.
perfectly fine model. But
It's
like,
a
wow, it's a
beautiful.
lot of data.
Yeah. Well, because now that makes me curious about that. Because looking at the steel 4, it's a similar curve as this reinforcing steel. And so I wonder if it's actually an improvement on it or not.
Steel
So
4?
yeah.
Well, I mentioned before that Steel 4 was developed primarily for BRBs. So
I think this one's like for maybe models buckling of rebar or something like that.
Yeah. So this was developed by
Sashi
and John Mole, who
not Meili, but Mole.
not
right?
Mele. Yeah, it's just really it was
At first
difficult.
glance, you think, oh, Jack
Yeah.
Meili, but no, it's John
Yeah.
Mole.
No.
Right?
Yeah. Exactly. So and he literally, it was a uniaxial material, and I don't think anybody really picked it up and improved it. But yes, it captures, it doesn't have symmetric tension and compression. Well, that's why your steel 4 is similar, because this could almost be used for a BRB then, because it does have buckling and anti-symmetric. As you can see, it's got 100 different options on things. But I could never get past just a tension compression test on it. I couldn't even do a moment curvature analysis. So, okay. This was very helpful, because now I know where to look for materials before I start using them.